Hello everyone, welcome back. Here's VanAmsen, and today we are going to tackle a very interesting problem, longest arithmetic subsequence, this time in C#. So it's medium difficulty problem, so it might be tricky to understand it and solve it efficiently, but we will explain everything. So we will try to use dynamic programming and also knowledge about the constraints that in this particular example are very important. So first understand the problem. We are given an array of integers and we need to find the length of the longest arithmetic subsequence in the array. So remember, sequence is in arithmetic is difference between every two consecutive number remains constant. And subsequence is a sequence that can be derived from an array by deleting some or no elements without changing the order. So we are given some test cases. So for example, if the array is 9, 4, 7, 2, 10, the longest arithmetic subsequence is 4, 7, 10. So difference between every element 4, 7, 10 is 3. And we need to output the 3, so the length of this sequence. So let's implement, and I will explain how we utilize it. So n will be num of length, and if n is less than 2, so return n, and longest will be initialized as 2, and int dp of new int n, and for int I less than n, increment, and dpi will be new int 1002, and array fill dp I with 1. And for j, 0, j less than I, increment int difference will be num1 minus num j and plus 501 to not go out of bound exception. So dpi difference, dpj difference plus 1, and longest will be max of longest element and dp of I at difference. So return longest we track. So let's run our code and see if it's working. So it's working, hopefully. Yeah, it's working. So as you can see, case we mentioned before is passed. So we can run it for unseen test cases and see how efficient is our solution. And I will explain right away what we did. So we beat 100% of other solution, and with respect to memory 83. So as you can see, it's quite efficient one. So we use the dynamic programming approach. The idea here is to create an array where each array keep track of maximum length of arithmetic subsequence that ends with a particular difference. And we start by iterating over the array from the beginning, and for each pair of numbers, we calculate their difference moving forward. And then we update the maximum length of the arithmetic sequence that can end with this particular difference. So we continue this process for all pairs of numbers, always updating the max length in a corresponding dp array. And in the end, we return the max length found during this process. And the beauty of this solution lies in the concept of cleverly reusing previously found knowledge and storing and updating findings as we progress through the array, rather than using some exhaustive search. And yeah, so remember, the key of mastering this kind of problem is practice, and the more problem you solve, the better you become in recognizing a pattern in problem and reusing in new one previously unseen. And yeah, if you like this video, please like it, and don't forget to hit the subscribe button for more coding tutorial challenges and tips. And as usual, keep practicing, stay motivated, happy coding, and see you next time.